So today we are going to learn about finding the area between two curves. So to find the area between two curves, first you're going to graph the curve by hand or on the calculator. Then you're going to find the points of intersection by setting the functions equal to each other or by using your calculator. Now you may not need to do this if they give you the upper and lower bounds in the problem. And number 3, you're going to integrate to find the area. And you can, on a calculator portion, obviously use Math 9. On a non-calculator, you're going to use your power rules. So the key is, if the curves are a function of x, the formula is that the area is the integral from a to b of f of x minus g of x. But f of x has to be greater than g of x. So in other words, if it's a function of x, you're always going from top curve to bottom curve. And your integrals, your bounds a, b, are on the x-axis. If the curves are a function of y, then the area is going to be the integral from c to d of f of y minus g of y, where f of y is greater than or equal to g of y. So that means you're always going from right to left, and your upper lower bound will be on the y-axis. So in the first formula, it's a function of x, so it's a y-equal equation, and the upper and lower bound are on the x-axis. In the second equation, it's an x-equal equation, and the upper and lower bounds are on the y-axis, and they're always right to left. Now, you're going to get the same answer either way, so it just depends on how the shape is, whether it's easier to go from right to left or from top to bottom. So if you look at your pass out, the reason the area of the region between two curves works is because what you're doing is you're making a little vertical slice rectangle, and you're accumulating all of those vertical slices when you do the integration. So then that makes up the area of the curve. So let's look at example. Find the area of the region bounded by y equal negative x and y equal x squared plus 2. X equals 0, x equals 1. So you know your lower bound and your upper bound. So if you graph these two equations, you'll see that they don't intersect anyway. So when you look at this, your top curve is the x squared plus 2. And your bottom curve is the y equal negative x line. So we're calling the y equal negative x line g of x, and the top one f of x. So when I go to do the area, I'm going to do the integral of 0 to 1. I'm going to put f of x first, so I'm going to put x squared plus 2 minus parentheses negative x. I'm going to integrate using my power rule, so I get x squared. Well, let's simplify first. You can get x squared plus x plus 2, and then you're going to integrate with your power rule, so you'll get x to the third over 3 plus x squared over 2 plus 2x, and evaluate for 1 and 0, and if you do that, you get 17/6. Now, if you were using Math 9, all you would have to do is type in the integral from 0 to 1, x squared plus 2 minus parentheses negative x. The only thing about the Math 9 is you've got to be careful on your parentheses. Now, let's look at the area between two intersecting curves. So if you were asked to find the area between f of x equal 2 minus x squared and g of x equal x, you notice you're not given any upper or lower bounds. So either with your calculator or algebraically, you would set them equal to each other. And you see, if you did it algebraically, you would get x equal -2, x equal 1. So then you're going to sketch the graph or do it in your calculator, either way. And so it's obvious between those 2 points that f of x is on top and g of x is on the bottom. So we just go from -2 to 1, 2 minus x squared minus x, and then we use our power rule and evaluate, and you get 9/2. So let's look at another example. Find the area between sine of x and cosine of x. Where do these curves intersect? So if you set those equal to each other, they are going to intersect at your tan of x's, which are pi over 4, 5 pi over 4. And so you could do it in your calculator also. So you see that the sine curve is on top, cosine curve is on the bottom. And so you go from pi over 4 to 5 pi over 4, sine x minus cosine x. Integrate using your formulas, and you'll get to square root of 2 as your answer. Now, especially want you to look at this next example, and on your handout it won't be in color, so I hope you can see it in the video, because in these two functions they intersect in more than 2 points. So if you've got f of x being -x squared plus 3x, and g of x being 2x cubed minus x squared minus 5x. If you set them equal algebraically, as you see, you'll get x equals 0, x equals 2, x equals -2. And you could do this in your calculator also if it's calculator active. So when you sketch it, you're going to see that it switches what's on top and what's on bottom. So if you look to the left, if you go from -2 to 0, then the g of x is on top, which they've indicated in the picture in the pinkish red color. And so you would integrate from -2 to 0, 2x cubed minus x squared minus 5x minus -x squared plus 3x. But then you would add from 0 to 2, you would switch it, because if you notice there, the blue equation, which is f of x, is on top and g of x is on the bottom. So you go from 0 to 2, -x squared plus 3x minus 2x cubed minus x squared minus 5x. And be careful, because when you minus those functions, remember it's minus to the entire thing. So then you would integrate either with your calculator or by your power rules, and you would get 16 as your answer. So you might want to try that and just see that you can get that. Now, let's look at one where there are x equal equations and that you're going to go from right to left. And a lot of times these are easier if you go from right to left. So if you look at the next picture, we got find the area with horizontal rectangles. So before, when we were doing y equal equations and our bounds were on the x-axis, they were vertical. You notice these little slices are horizontal. And so when you're doing an x equal equation, you're going right to left. So if you look at this, you've got x, or f of y, equal y squared, and then you've got x equal y plus 3, which is g of y. Now, to put it in your calculator, if you needed to do that, of course, you would have to convert them to y equal equations to do that. If you didn't want to do that, or it was on a non-calculator part, you would just make your little table of points, x and y, and plug in there till you could get it. But as you can see, g of y is the curve that's to the right, and f of y is the curve to the left. So we're going to go from -1 to 1, and we're going to do y plus 3 minus y squared, and then integrate using your power rule, and you get an answer of -2/3. Now, let's look at one where you do it both ways. And this is a resource I pulled from the internet because there's no point in reinventing the wheel, and I found a small error at the bottom, so I'll show it to you because the answer should be the same on this, whether you do it x or y. So we've got find the area between x equal 3 minus y squared and x equal y plus 1. So they're x equal equations. So let's look on the right side first. If we were looking at the y-axis. And probably if the problem was given to you this way, this would be the easiest way to do it. So if you graph that, you're going to see that they intersect from -2 to 1. And a lot of times they'll just tell you what bounds to use. So we would integrate from -2 to 1 f of y minus g of y, because f of y is the curve to the right. So we would have 3 minus y squared minus y plus 1. And if you do your power rule, you'll come down 9/2, which is the correct answer. Now let's look at a more difficult way, but can be done. The equations were given to you in x equal, but you could convert them to y equal. So x equal y plus 1 would become y equal x minus 1. But x equal 3 minus y squared, we'd have to do y squared equal 3 minus x, and then y equal plus or minus the square root of 3 minus x. So if you look at this graph, from -1 to 2, your x minus 1, that line right there, is on top. And then past 2, your positive square root of 3 minus x is on top, and your negative square root of 3 minus x is on the bottom. You don't even have the f of x come into play for that. So what you would do is you would go from -1 to 2, and you would do x minus 1 minus parentheses minus square root of 3 minus x, because that's the negative part of that curve. And then you would add from 2 to 3 the positive curve minus the negative curve, because the positive's on top and the negative's on the bottom. So notice your bounds are different. A lot more work on this. This is a much easier way to do. And if you come down, you can see how it's integrated. Whoever did this made a slight careless error here. This should be 4/3, and I'm going to correct that on your paper. If you do the math, you'll see it's supposed to. So then if you made that 4/3 instead of 2/3, you're going to get the same answer, 9/2. But hopefully you see you want to use the method that's the easiest.